Did you know there's an asteroid floating out there right now that could make every single person on Earth a trillionaire? It's called 16 Psyche. It's about the size of Massachusetts, and it's packed with so much iron, nickel, and precious metals that scientists estimate it's worth roughly $10,000 quadrillion. That's a 10 with 18 zeros after it. That's more wealth than currently exists on the entire planet by a factor of about 100,000. And here's the crazy part, 16 Psyche isn't even that special. There are thousands of asteroids out there just like it. Some contain trillions of dollars worth of platinum. Others hold the rare earth elements we desperately need for our smartphones and electric cars. A few even have water, which in space is more valuable than gold. Right now, as you're watching this, countries and private companies are in a race, investing billions to develop the technology to mine these asteroids. But this is where it gets complicated. Nobody really knows who owns space. The laws are vague and outdated. As we get closer to actually mining these celestial bodies, tensions are rising. We could be witnessing the start of the greatest resource competition in human history. Not for oil in the Middle East, but for asteroids, moons, and planets millions of miles away. Today we're diving deep into the new gold rush. What's actually out there? Who's trying to get it? And who gets to keep the prize? This isn't science fiction anymore. This is real, and the decisions made today will shape the superpowers of the next century. So let's start with the big question. What is actually in space that is worth all this trouble? The short answer is everything. Space is full of resources that are rare and expensive on Earth but incredibly common out there. First, let's talk about the obvious targets. Precious metals like gold and platinum. When Earth was formed, most of these heavy elements sank to the core, making them rare on the surface. But asteroids are different. They're like flying chunks of a planet's core, with all those valuable metals mixed right in. A single small metallic asteroid could hold more platinum than has ever been mined in human history. Another asteroid, named Davida, is estimated to contain metals worth hundreds of trillions of dollars. But what's even more important than gold are rare earth elements. You've probably never heard of materials like neodymium or dysprosium, but they are essential for all modern technology. They're in your phone, your laptop, electric vehicle motors, and advanced military hardware. Currently, China dominates the global supply, giving them huge strategic power. Space offers a way to break that monopoly. Mining rare earths from asteroids would secure our supply chains for all the tech we depend on. From a national security standpoint, this might be the real prize. Now for the most surprising resource: water. In space, water is more valuable than platinum. Why? Because water is rocket fuel. You can split it into hydrogen and oxygen, the most efficient rocket propellant we have. Right now, every trip to space is limited by how much fuel you can carry from Earth. It's a massive constraint. But if you could refuel at a gas station in orbit, everything changes. Launches become cheaper, and we could travel much farther to Mars and beyond. The moon has ice at its poles. Asteroids have water. The first group to control this water supply will essentially control the highways of the solar system. And that brings us to the long-term goals: the moon and Mars. The moon has helium-3 for potential fusion energy, plus titanium and water. Mars has iron, aluminum, and an atmosphere we can process for fuel. This isn't just about bringing resources back to Earth. The ultimate vision is to build self-sustaining industrial bases in space, creating a true space economy. The race has already begun, and the stakes couldn't be higher. What happens next will define humanity's future, both on Earth and among the stars. So we know space is loaded with valuable stuff. The big question is, who's actually trying to get it? Let's start with the early leader, the United States. America has dominated space since the Apollo era, and they're using that head start for space mining. Back in 2015, the US passed a law that basically says American companies can own and sell whatever they pull out of asteroids. It was a bold move, maybe even a violation of international law. But the message was clear. We're not claiming the asteroid, but we are claiming what's inside it. NASA's Artemis program to return to the moon even has plans to mine water ice. And then you have the private companies. Early pioneers like Planetary Resources struggled, but new players like Transastra and Astroforge are making real progress, raising millions to develop tech for mining water and precious metals. But there's a rising challenger: China. They've made it crystal clear that space resources are a strategic priority. Their space program is advancing at lightning speed with moon landings, sample returns, and their own space station. In 2021, China and Russia announced a joint plan for a lunar research station, with resource extraction as a key goal. They see it as an alternative to the US-led Artemis program. Strategically, China views space resources as a way to secure its economy and gain an edge. Now for a surprise player, Luxembourg. This tiny European country, with a population smaller than many cities, has smartly positioned itself as a global hub for space mining. In 2017, they passed their own laws allowing companies to keep resources from space and even set up investment funds to attract them. Why? They're thinking long-term, aiming to become the financial and legal center for the space mining industry. And it's working. Of course, other countries are in the mix too. Russia, a historic space power, is partnering with China. Japan is a leader in asteroid sample return missions, proving the tech works. And the United Arab Emirates, looking beyond oil, has launched missions to Mars and openly stated that space mining is part of their future economic strategy. Now, let's get into the biggest headache for space mining, the law. Is any of this even legal? The foundational rulebook is the 1967 Outer Space Treaty. It says space is for everyone, and no country can claim ownership of the moon or an asteroid. But it's silent on whether you can actually take stuff from them. It's like saying no one owns the ocean, but not mentioning if you can go fishing. This ambiguity is a huge problem. In 1979, the UN tried to fix this with the Moon Agreement, which said space resources are the common heritage of mankind. Sounds great, but none of the major spacefaring nations, the US, Russia, China ever signed it. So it's a treaty with no real power. Frustrated by the lack of clear international rules, countries are just making their own. The US, Luxembourg, Japan, and the UAE all have national laws saying their companies can own space resources. This works at home, but what happens when an American company and a Chinese company both want to mine the same asteroid? There's no international court or police to sort it out. To create some order, the US introduced the Artemis Accords in 2020. It's a set of principles for cooperation, setting up safety zones around mining sites and promoting transparency. Over 30 countries have signed on. But guess who hasn't? China and Russia. They see it as a US-led effort to cement its own dominance. So now we have two competing visions for how space should be governed, which is a recipe for future conflict. Legal issues aside, space mining is an incredible technical challenge. First, just getting there. Chemical rockets are great for launch, but for long trips to asteroids, you need super-efficient electric propulsion, like ion drives. NASA's Dawn mission proved this tech works, and private companies are now building their own. Next, you have to find the right targets. Not all asteroids are created equal. This means using telescopes and sending out small, robotic prospecting probes to scan hundreds of asteroids and find the most valuable ones. Then comes the hardest part, extraction. You've reached an asteroid, and now you need to mine it in zero gravity, with no air, using robots. Some ideas involve scooping up loose surface material. Others involve baking the asteroid to release water vapor. For metals, you might use magnets. All of this has to work perfectly, millions of miles from Earth, with no chance for a repairman to visit. After you've got the raw material, you have to process it. Raw asteroid rock isn't useful. It needs to be refined, which takes a lot of energy. Where does that come from? Solar panels are an option, but what if you're far from the sun? Maybe you use the asteroid's own resources, like turning water into fuel, to power your operations. Finally, you have to get the goods home, or at least to where they're needed. Bringing platinum back to Earth means surviving a fiery re-entry. Keeping water in space for fuel depots means transporting it across the solar system. The whole enterprise only makes sense if it's cheaper than just launching everything from Earth. That's a very high bar to clear. So the race for space resources is on, with huge economic potential and massive legal and technical hurdles to overcome. The next few decades will determine if this new frontier brings humanity together or pushes us further apart. Let's zoom out and think about what space mining means strategically. You could call it the new great game. Space mining could reshape global power dynamics as dramatically as the discovery of oil did in the 20th century. The nations and companies that control space resources will have enormous economic advantages. They'll have access to materials competitors don't. They'll control fuel supplies for space activities, and they'll have the wealth to fund even further expansion. This creates what's known as a first-mover advantage. Whoever establishes dominance early might be able to maintain it, much like how Britain's early industrialization gave it a century of global dominance. China understands this, which is why they're investing so heavily despite the enormous technical challenges. They don't want to find themselves dependent on American space infrastructure the way they currently dependent on American GPS satellites. But space mining isn't just about economics. It has direct military implications. The same technologies used to mine asteroids could be used to manipulate them. A spacecraft designed to redirect a small asteroid to lunar orbit for mining could, in theory, redirect an asteroid toward Earth as a weapon. Now that sounds like science fiction, but military planners take it seriously. The technology to deflect asteroids away from Earth, which we recently demonstrated with NASA's DART mission, also gives you the technology to potentially direct them toward Earth. Plus, control of space resources enables military space activities. If you have fuel depots in orbit, you can maintain military satellites more easily and respond to threats more quickly. The U.S. Space Force was created partly with these considerations in mind. Space is becoming a domain of military competition, and resource control is a key part of that. Here's an interesting twist, though. Space mining might actually be better for Earth's environment. Mining on Earth is incredibly destructive. It pollutes water, destroys ecosystems, and generates enormous carbon emissions. Rare earth mining, in particular, is extremely toxic. If we can shift some of that mining to lifeless asteroids where there's no environment to damage, it could significantly reduce the environmental impact here on Earth. Of course, that's assuming space mining is actually economically viable and doesn't just become an additional source of resource extraction on top of what we already do here. And what about the economic disruption? If space mining succeeds at a large scale, it could completely disrupt commodity markets. What happens to platinum prices if an asteroid with more platinum than Earth's entire crust suddenly becomes accessible? What happens to countries whose economies depend on exporting metals? South Africa derives significant income from platinum mining. Russia exports large amounts of nickel. The Democratic Republic of Congo depends on cobalt exports. If space mining provides alternative sources, these economies could collapse. This is similar to how fracking disrupted global oil markets and hurt countries that depended on high oil prices. The economic winners and losers of space mining could reshape global wealth distribution dramatically. So when is all this actually going to happen? Are we talking decades or centuries? Well, in the near term, over the next 5 to 10 years, we'll likely see significant milestones. NASA's Artemis program aims to establish a sustainable presence on the Moon, including water ice extraction demonstrations. This could happen as early as the late 2020s. Private companies are planning asteroid prospecting missions in the next few years. These won't be full-scale mining operations, but they'll gather crucial data. The first space resource to be utilized will probably be water from the Moon or near-Earth asteroids. It won't be brought to Earth. It'll be processed into fuel for use in space. This is the most economically viable near-term application because launching water from Earth is expensive, and the demand for fuel in space is growing. In the medium term, say 20 to 30 years from now, we might see the actual extraction of metals from asteroids, though probably still on a small scale. The first operations will likely target platinum group metals because they're extremely valuable per kilogram, making the economics more favorable. We might also see industrial facilities on the Moon producing building materials for space construction. Instead of launching everything from Earth, you'd manufacture structural components and radiation shielding from lunar resources. And in the long term, 50 to 100 years out, if space mining succeeds, we could see a genuine space economy. We're talking fuel depots at strategic locations throughout the inner solar system, manufacturing facilities on the Moon and Mars, and asteroid mining operations scattered across the asteroid belt. This sounds like science fiction, but so did satellite communications and GPS 50 years ago. Technology often progresses faster than people expect. Of course, all of this assumes we can overcome some massive challenges. The economics need to work. Right now, it's vastly cheaper to mine resources on Earth. Space mining needs to become competitive. The technology needs to mature. We've proven concepts on small scales, but industrial-scale autonomous mining in space is orders of magnitude harder. The legal framework needs clarity. Companies are hesitant to invest billions if they're not sure they'll legally own what they extract. And then there's the political challenge. If space mining starts creating winners and losers among nations, diplomatic tensions could escalate into conflicts that slow or even stop development. So after all that, who's actually going to win this space mining race? If I had to place a bet, right now the United States is in the strongest position. They have the most advanced private space industry, the most capital, and the most developed technology. Just think about SpaceX's Starship. If it succeeds, it will absolutely slash launch costs and make space mining way more affordable. That's a massive advantage for American companies. But you can't count China out. They're playing the long game, building up their capabilities step by step. They might not be the first to mine an asteroid, but they could catch up very quickly once the technology is proven. The winner might not even be a single nation. It could be a coalition like the countries in the Artemis Accords, working together. By sharing infrastructure and tech, they could collectively dominate space resources. Or the winner could be a private company that develops some breakthrough technology and establishes dominance before governments even get their act together. We saw this happen with commercial satellites, and history could repeat itself with space mining. My best guess? There won't be a single winner. It's more likely that different players will control different resources and locations. The US will probably dominate near-Earth asteroids and lunar operations. China will likely establish a strong presence on the moon's far side and maybe even Mars. Private companies will find their own niches, operating more efficiently than governments in certain areas. This isn't a winner-take-all race. It's going to be a complex, evolving competition with multiple players and shifting alliances. We've covered a lot of ground today, from metal-rich asteroids worth quadrillions of dollars to the legal mess surrounding space ownership, from the technologies being developed to the strategic competition between nations. Here is the main thing I want you to take away from all this. Space mining isn't some distant sci-fi fantasy. It's an emerging reality that's going to reshape our economy, our politics, and our entire civilization in profound ways. The decisions being made right now, which laws get passed, which companies get funding, which technologies get developed, how international agreements are negotiated, these decisions will determine the future of space for generations to come. We are in the early stages of what could be humanity's greatest expansion since we first left Africa thousands of years ago. Space mining is the economic engine that could make large-scale space settlement possible. But we're also potentially setting up the next great conflict. If space just becomes another arena for winner-take-all competition, where nations fight over resources and strategic advantages, we'll have failed to learn from Earth's long history of resource wars. The Outer Space Treaty tried to establish space as the province of all mankind, a place for cooperation, not conflict. Whether we actually achieve that vision or just repeat the mistakes of colonialism in a new environment, well, that's up to us. What do I think will happen? Honestly, probably a bit of both. Competition will drive rapid development and innovation. But if we're smart, we'll also build frameworks for cooperation that prevent destructive conflicts and ensure space benefits all of humanity, not just a few powerful nations or corporations. The resources are out there, the technology is developing. The competition is heating up, the space mining race has officially begun. And the outcome will determine not just who gets rich, but what kind of species we become as we expand beyond Earth. So here's my question for you. Do you think space should be treated as open territory for whoever gets there first? Or should there be international rules ensuring space resources benefit all of humanity? Is space mining going to be more like the Age of Exploration, or more like Antarctica's international treaty system? Drop your thoughts in the comments. And if this video opened your eyes to a competition happening right now that most people don't even know about, hit that subscribe button. We're covering the stories that will define the future, not just today's headlines. The next resource war won't be fought over oil fields or lithium mines. It'll be fought over asteroids, moons, and planets millions of miles away. And it's already begun. See you in the next one.